Right, yes. Right, so we can start the session. Right. We were talking about the continuity, right? Continuity, first of differentiability is a little far away. So the very word says that continuity means what? It should not be broken anywhere, correct? It should not be broken. So when a curve is given like this, do you find here any break spine? Say some from here to here, if I restrict the x, say this is called minus 2 pi and this is called 2 pi. In this domain of theta, you just check me from minus 2 pi to 2 pi, you see a graph here and see this how continuous it's going. I can draw the graph of it without lifting my pencil, my pen, chalk paste in this case. So do you find any breaks in between? No. So we can say that this function is continuous. That means one beautiful, which is easily comprehensible to us about the continuity is that if any graph can be retraceable without lifting the pen from one end to other end. Please understand this, please. If one can draw, if one can retrace, please listen, if one can retrace the graph without lifting pen bar, pencil bar, chalk, okay, whatever, chalk, one can retrace the graph without lifting the pen or pencil or chalk. We say the graph, we say that function, graph is continuous. That's all. Yes. So this is one soft way of defining one. Nama language la solradhukku nama English la vandu indha maadhiri sollala continuous. But it's not going to serve the purpose, right? They don't give the graphs every time. They give a mathematical description of a function, and you must be able to say from that description whether the function is continuous or not by drawing its graph. By drawing its graph. So this is fine. When I see the graph, from the graph I can see this. So it's a continuous, yes, pass. But when I give a description, mathematical description, okay, now rather English description, whether we will be able to understand that and say the function is continuous or not. Okay, you can take one small case here. In that, I describe mathematically like this. And you can plot it, and from the plot you can say, so that means what? If any function is graphed, we could easily say whether it is continuous or not. But then vice versa, no definition is required, correct? No need of any mathematical formula. So if any function is given, if I can plot it, I can say whether it is continuous or not. But the problem is, are we capable enough to draw the graph of any function? That's the problem. Always it is not possible. We are not capable to draw the graphs of many functions. We are limited. Our resources are limited. So There are three cases. One is graph is given. Easy to say whether the function is continuous or not. Number two, function is given. Function description is given. Functional description is given. Mathematical description of function is given. And without definition, is it possible? That means function is given. You have to draw a graph for it. Draw a graph for it. Draw a graph. Draw a graph for it. Now also it's possible. Function is given. You should draw. You must be able to draw a graph. Then also you can say the function is continuous or not. But number three, function is given. But I don't know how to draw the graph. I do not know how to draw the graph. Here you can't do. Here you can't say. Right? You can't say here. Right. Yes, therefore, what you require is here, the function is given, I don't know how to draw the graph, then there must be a mathematical definition for continuity that will tell us, without drawing the graph, we could say the function is continuous or not. See, the fourth one is that function is given, I know mathematical formula, I know mathematical formula of continuity. For continuity. Now, without I can't draw the I need not draw the graph. I can say from this. So finally, what we have concluded is that function is given, and I know the mathematical formula for continuity. What is that mathematical formula for continuity? Okay, that I will describe slowly. Okay, whatever definitions we won't get much understanding of it. Okay? Lots of definitions are just left gone to the dustbin because we have not put enough effort to understand that. And the components of that formula we have not made it clear. Therefore, what I do is I go through the components to the formula. Okay? So, what is that formula for a continuity? How to define the continuity mathematically? Okay, any function to be continuous or not. Any function to be continuous rather. Okay. Ninga, you just take some few functions that will make ample clear to you. That will make you ample clear whether they are continuous or not. Now, I'll give you now. Just textbook things only I'll give it, so that when you go home and check, please read, see now, in the continuity first 3 to 4 pages. Kindly write in the notebook. Kindly write in the notebook. 3 to 4 pages. Right? Such a beautiful concept it is, continuity concept, and then it's connected to differentiability concept. So in the rendu and the limit also, limit to continuity, differentiability. These three, if you can understand it, I think calculus is done. So for that, now I am going to give this one. I am going to finalize this mathematical formula for continuity. For that, what I tell you is, now I have got one function here. F of x equal to 1 if x is less than or equal to 0. It is 2 if x is more than 0. Formula. Let's see. Now let us plot. I don't know the definition, but let us plot it. We can plot it very, very simple. Take x-axis and y-axis, rectangular coordinate system. This is x-axis and y-axis. Here y-axis level the f of x into. On y-axis I have taken f of x, and x-axis I have taken x. Wonderful one. He said that x is greater than 0. X is greater than 0. This is 0, x is 0. He didn't talk. When x is 0, it is 1. X is 0, it is 1. X is 0, it is 1. X is less than 0 also, it is 1. Less than 0 also, it is 1. Any value you take it. Say this. Now, x is more than 0, it is 2. This is 2. At 0, it is not 2. At 0, it is 1. This is 1. This is 2. At x is more than 0, it is 2. This is the graph of this function, for a beautiful function. But when I say from descent to descent, I go here. This is not a graph of it. This is only x and y axis. Is there any connection? Please tell me. Is the graph is continuous, my dears? Please tell me. All of you, please tell me. Is the graph is continuous? No, yes, Pa? Hare Krishna, you said, I'm not clear. No, once again, repeat. No, oh, it is not continuous. Wonderful. It is not continuous, Pa. Please. From here, you come here. From here, you go there. And from here to here, you have to lift your pencil and further continue. Therefore, the function is not continuous. The reason is that we are able to draw the graph of it. We are here. Now, I want to come to this one. I'm slowly, I'll give one more case. Please take this one. And it's very clear that from 1 to 2, we have to jump, right? We have to jump. No continuity. Right? Wonderful. Let us take one more case. Yes, if you please, whatever I wrote on the graph, please write it. Let us see the next graph, man. Let us see the next function. F of x equal to 1 when x is not equal to 0. F of x equal to 2 when x equal to 0. Aha, how beautiful it is. I will draw the graph of it. All of us can draw the graph for it. See, but when he said that x is not equal to 0, what does it mean x is not equal to 0? X could be positive or x could be negative, but not 0. So when x is positive, x is negative, it is always 1. X is positive. At x equal to 0, it is 2. At x equal to 0, it is 2. At x equal to 0, minus 0x. Y is what? 2. At x is not 0, we are here. More than 0. Another empty circle. At 0, it's not 1 years. At x equal to 0, it is 2. Therefore, at x equal to 0, it is 2. That's why circle is here. Circle means what? Full shaded circle is there. Here, empty circle is there. Reason is that this is 1 mark. At x equal to 0, it is not 1. It is 2. But at x is more than 1, it is 1. Similarly, here like this. Aha, how beautiful it is. But is it continuous, please? Anybody? Is it continuous, yes?
No, sir.
No. Brilliant answer. No. The reason is, once again, the only one break is there now. Only one obstacle is there here. At x equal to 0, it is 2, not 1. Definitely, it's a continuous. So, is it continuous means answer is what? No. Right? Now, first one and second one. X is more than 0. F of x is 1. X is less than 0. F of x is 1. Now, what additional feature you have to incorporate? Yes, please tell me. Anybody? At x equal to 0, if f of x equal to 1, correct? This is additional line. In the problem we resolve pannadukuma, yes, if I want to transform this function to continuous, please. If I want to transform this function to continuous, this is okay. At x equal to 0, f of x equal to 2 எடுத்து பாருங்க. இந்த 2 வந்து நம்ம என்ன மாத்தணும்னா 1 ஆ மாத்தணும். Then this will become the 2 இல்லப்பா இந்த 1 ன்னு போட்டா that's all. It will become continuous பாருங்க. So நீங்க at x is more than 0, at x is less than 0, at x equal to 0, if all the three values are same, then I say that a function is continuous at x equal to 0. We are talking about 0. At 0, the function is continuous. When all the three are equal. Yes, all the three are equal. I hope it is clear. Have you taken the previous figure for this? Friends, here x is more than 0, which means what? X tends to 0 plus. Please note down this notation here. Very important here. X is more than 0 means what? You can transform this to x tends to 0 plus. X is less than 0 means what? X tends to 0 minus. And x equal to 0, that's nothing like x equal to 0. X equal to 0. That's no need to cancel on that, okay? X equal to 0 is x equal to 0. Yes. Write down this notation. So from this, what I can conclude is what? To say a function is continuous, at x equal to a, at x equal to some a or b or c, at x equal to c report, okay? At x equal to c. In some interval, okay? Interval a comma b. Interval a comma b. To say a function, to say a function is continuous at x equal to c in the interval ab. AB. We say that limit x tends to c plus f of x, limit f of x c minus c extends to c minus, that's equal to f of c minus f of c. All of this, that's all this. This value, if all the three are same, then we say that the continuity, the value of the function at x equal to c is same before, after, and at. That's the need of our continuity notice. Note down this one. C plus limit x tends to c plus f of x. This is called a right hand limit. This is called left hand limit. That's equal to f of c. இதே வந்து டெக்ஸ்ட் புக்ல வந்து இன்னும் ஷார்ட்டா சொல்லிருக்காங்கப்பா. இந்த ரெண்டு வந்து you can write it as limit x tends to c, and that's equal to limit x tends to c f of x is equals to f of c. இது சொன்னாலும் இது மூணு சொல்றது பதிலா ஒன்னு இந்த ரெண்டு சொல்லலாம். This is but whichever, this is the preferable one, so that you will have always handy this one. Okay, so left to right and that's it, right? So either note pannikoma this one. Okay, இது சொல்லிருக்காங்க. பட் இது ஆல்ரெடி லிமிட்ஸ் நமக்கு தெரியும். லிமிட் x tends to c f of x is nothing but limit c plus and c minus. This is equal to these two. This is this one. So the short form is an expansion form. So this is the definition of a function to be continuous. Or suppose all the three values are equal, we say yes, the function is continuous at c. If one of them is mismatches, we say with what's a lot of authority, you can say that the function is not continuous. I hope it is clear.
Yes, sir.
Right. Okay. So using this definition, we can do the questions properly. Starting with 5.1, straight away I will go to exercise and work out. In the definition, apt questions first solve. Okay, I'll take some selective questions, particularly split functions. Let us take to understand this definition well. Okay, then I will see different other questions also, one after the other. See now. So let us record this definition here, please, for continuity. The definition is like this, mathematical definition is like this. Limit x tends to c plus f of x. Limit x tends to c minus f of x and f of c. This one, let's keep it here. Permanently you can see. Yes, see 2 days, okay? Right? Let us start the question number 5, please. Okay, let us start the question number 5. Is the function f defined by? Is the function f defined by? Function of pair on the f mark. Fun, all time f function f function f defined by. Yeah, f of x equals to x if x is less than or equal to 1. It is 5 if x is more than 1 or this. That is the formula. Is the function f defined by? This is the function continuous at x equal to, you have to say yes or no. Is this function is continuous at x equal to 0? Number 1. At x equal to 1. Number 2. At x equal to 2. Yes. These are the 3 things, my dears. One point. C is 0, C is 1, C is 2, my dears. First one, you take at x equal to 1, so it's easy to, look at x equal to 1, nama check panla first. 0 upon panla, 2 panla, okay? So friends, here, at x equal to 1, to say the function is continuous at x equal to 1, it should satisfy this one. So friends, at x equal to 1, number 1, limit x tends to 1 plus f of x, limit x tends to 1 minus f of x, and f of 1 ds. Okay, this is how as the definition goes, correct? That means c is 1 minus c badla nama 1 4 c another x value dama. C is in the domain of x ds. So x value is that. C is also x value, 1 is also x value, 0, 2, ellame values of x minus. Pardon, please. ஏதாவது நீங்க டவுட் இருந்தா தயவு செய்து கேட்கணும். Please, whatever I can do the help, I can definitely do. Please, at x equal to 1, yes. First, 1 plus anna, please tell me, 1 plus anna, is the function is what now? This is a x is more than 1, x is less than or equal to 1. What do you understand by 1 plus, Harni?
Value is greater than 1.
Greater than 1, what is the value of the function?
5.
When x
If x is greater than 1.
f of x another 5 mark. When x is more than 1, f of x is 5. When x is less than or equal to 1, the function or name is x. Function value is x. Put it on, please. So, you can replace formula. Limit x tends to 1 plus f of x. F of x is 5 when x is 1 plus more than 1. I already told ma 1 plus means what? Yes, 1 plus anna more than 1. 1 minus anna less than 1. F of x for the another formula. Okay, right, 5. Wonderful. Equals to limit x tends to 1 minus. Okay, it's okay. First is 1 plus. The value here, there is no variable to substitute the value of x here. Therefore, it's always 5. Number 1. Number 2, limit x tends to 1 minus. X 1 minus. What is f of x ma when x is less than 1 ds? Mamati.
X.
What is the function? X, brilliant, x. இங்க வந்து இப்ப x இருக்குன்னா he is talking about something here. X tends to 1 minus. What do you mean by x tends to 1 minus, dears? X is approaching 1 from less than 1 side, 0.99. Okay, so what? But value of x is what? 1 only. It is almost equal to 1, but not 1. It's very, very close to 1. So, the x value is 1 x value, then the limit will disappear. But once you substitute the value of x in the function, it will disappear, limit will disappear. The value of the limit is now 1 mark. Okay, done. Next, Akshaya, what is remaining? Tell me. F of c, f of 1. At x equal to 1, what is the function, ma, please? Akshaya. At x equal to 1, what is... Yes, pa, once again.
1, sir.
Illama, something, please. You are right. Listen. At x equal to 1, what is the function? Is it more than 1? Is it less than or equal to 1? What is the value of the, what is the function here? X. Correct?
Yes,
At x
sir.
Therefore, put x equal to 1 here. You are right, it's 1. Okay, f of 1 is 1, no doubt. In the form x இருக்குது. So you have to put x equal to 1 because f of 1, x equal to 1 போட்டோம். இந்த x இருக்குனால 1 plus. So this is the RC. Look at these things now. Are these three values are same? Say it all of you, please. Are these three values are same? No, that means limit x tends to 1 plus f of x is not equal to limit x tends to 1 minus f of x is equal to f of x, f of 1 is correct. So these in the equal, but it is equal to area. Therefore, the function is not continuous. Not continuous at x equal to 1, yes, x equal to 1. Note panakoma. Then we will go for 1 and 2. At 2, 0 and 2 polar. Right part clear?
Yes, sir.
Not continuous at x equal to 1 ma. Let us say at 0, yes, now. At 0. Second ma, second. At x equal to 0. Harini, tell me here. 0 plus. Say it, say it. 0 minus. What is it here?
F of 0.
Brilliant. F of 0. In the Soluma, Akshaya, in the Soluma here. What is this ma, please? 0 plus ma. 0 என்றது எங்க இருக்குமா please? 0 என்றது x is more far. I will write it here. X is less than or equal to 1 ma. This is 1. Sorry. Like this. X is more than 1 and is 1 in the same. Just please understand this. நான் இப்ப என்ன கேக்குறேன் 0 கேக்குறேன் 0 என்றது இந்த இன்டர்வல்ல இருக்குதா இந்த இன்டர்வல்ல இருக்குமா ப்ளீஸ் டெல் ஃபர்ஸ்ட் ஒன் ஆர் செகண்ட் ஒன் எஸ்
First one.
First one brilliant இப்ப ப்ளீஸ் லிசன் 0 பிளஸ் என்றதுக்கு வாட் இஸ் த ஃபங்க்ஷன் டியர் ஸ்டூடண்ட் function is 0 plus 0 is 1. 1 is 1. You said 1. So 0 is here, correct? Yes or no?
Yes, sir.
Yes, sir.
Yeah, right. 0 is the function. So what is the function now? For 0 plus. Yeah. 0 plus is here. 0 plus is here. 0 minus is here. For 0 plus, 0 minus and 0 for all of them, what is the function, dears?
X.
Brilliant. X. That's all, yes. X. Right? Limit x tends to 0 minus x. Function is x. And f of 0. F of 0 is 0. F of 0 is 0. So, you பண்ணவே தேவையில்லைப்பா. Once the seed yes. For x equal to 0, same function ma. Whenever x is less than, not only for 0, you take a minus 1, minus 2, minus 3, all values. See, you can see this. I just write it once. X is less than 1, it is x. And x is more than 1. More than 1, it is 5 years, more than 1. And x is less than 1, it is less than or equal to 1, it is f of x equal to x ma. Wow. Now, can you tell me, particularly except at this ma, please? Discontinuous, of course, it will join here. Except at x equal to 1, everywhere now you see, suppose you want say at 0 ma. 0, do you have any break ma? At 0, do you have any break in the function? No. At 2, do you have any break in the function? This is 2. 2 neighborhood break illa. Therefore, the function is continuous at 0 and 2, but not at 1. It's the graph. Is the graph, but graph illame பாருங்க x எல்லாமே ஒரே இருக்கு பாருங்க same function x same function x same function x மா put x equal to 0 minus 0 0 0 all the three are equal hence the function is continuous at x equal to 0. This is x equal to 0, it's a continuous ma, nowhere at x equal to 0 there is no break. I hope it is clear, right? Yeah, only at x equal to 1, you will find a empty circle, yes. Purinjikoga, please. Actually, this is at x equal to 1, I think my graph is not correct. It is x, right? X and x, y, then 1 by 4. Now x equal to 1, this is 1, okay? It is 5. Yeah, this is the graph, yes, this is the graph. At 1, at x equal to 1, link therefore you can't connect it, you have to jump, okay, you have to lift your pen and draw the graph. Therefore at x equal to 1 it is discontinuous, and at all other points below 1 and below 1 and above 2 and here 2 right? 2 and above 1 this are the 2 or 3 or 4 or 5 anywhere you take 2 or 5 or 7 or anywhere, the function is continuous, my dears. The value of this, the height is 5. The height is 5. The height is x equal to y equal to x. When x equal to 1, y is 1. When x equal to 0, y is 0. That's called y equal to x. Y equal to x. So when the function is safe for all the 3 cases, particularly for these 2 cases, you can conclude, my dears, you can conclude that function is continuous. Right? Next, paranga. Even for what do you conclude about 2, my dears? Anybody, 2 into 1 mark, 2 and mark. At x equal to 2, can you say Harvey is it continuous or discontinuous, mark?
Continuous, sir.
Why? At 2 plus, what is the value of the function, dears? At 2 plus, what? 5, brilliant. At 2 minus also? 5. At 2 also, 5. Therefore, it is a continuous at x equal to 2. That's all it is. You could see from the graph also, mark. 2 neighbors 5 parallel line, yes, parallel line, mark. 2 plus 5 minus 1 5 at 5 at 2 it is 5 only. Therefore, the definition holds good. I hope I understood very well, ma, please. I hope you are also getting it. Yes, very clear? Not only 2 dears. You could ask for 3, 4, 5, any number more than 1, you give it. It is continuous at every, not only integer point, even non-integer points, my dear, but it should be more than 1. Here, less than 1, any point.
Sir.
Yeah, ma?
Sir, for 2 minus, first function also will be possible only, no, sir?
First function, once again.
For
the first one, 0, x equal to 0.
Sorry. No, sir. Minus.
Purila, once again.
Sir, for 2 minus, sir, we can also use that x is less than or equal to 1 function, sir.
No, array, dear. Array, my dear, I'll tell you one thing, please. Yeah. You get that idea, please. I appreciate it. My dear, limit x tends to 2 minus anna. What does it mean, my dear? Please let us understand this, ma. Please take this first. At x equal to 0, it is a continuous. At x equal to 2 also, it is continuous, ma. And x equal to 1, it is not continuous, yes, okay? Not, yes. Right, I will explain this, Hari. Yes, you are right. Your point is genuine, I will explain. Yeah, that's a very, very genuine doubt, okay? Yes, I'll give you a beautiful explanation for it. Watch here. Yes, when I say limit x tends to 2 minus, this is 1, right? This is 1. More than 1, right? The 2 here, come on. Okay. It doesn't mean that 2 minus means I can come some 2 kilometers or 4 kilometers back of 2. No. What is 2 minus? 2 minus is, it's a very, very small value less than 2. 2 minus is nothing but what? Yes, it is 2 minus delta x. Small value, yes. Small value, it's a neighborhood of 2 ds. It is that word we have to use it, ma. 2 minus and 2 plus are very much neighborhoods of 2. You don't get the idea that you cannot be what to say, in isolation ma, somewhere 1 and below 1, it's not neighbor ma. Then everything collapse, correct? But meaning of 2 minus and 2 plus are what? They are very, very close to 2. That means they are neighbors of 2. Close neighbors of 2. Please. 2 minus and 2 are close neighbors of almost equal to 2 ds. And they are very, 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 very close neighbors of 2 ds. Is it okay, Ani?
Yes, sir. Understood, sir.
Thank you. That's all. I hope you have taken this point too. Yes, this point is brilliant point. That generally get a doubt. Right. So for this question, we have completed at 1, not continuous. Question number 5. Or 3P, I will conclude it. At x equal to 1, not continuous. At x equal to 0, yes. At x equal to 2, yes. Next, x equal to 3, 4, 5, anything like this. X equal to 2, 3, 4, 5, anything is fine, ma. X equal to 0, x equal to minus 1, x equal to minus 2, 0, minus 1, minus 2, minus 3, anything less than 0, less than 1, all are continuous, yes. That's a yes. இதே மாதிரி நம்ம 6th one பார்க்கலாம், 7th one பார்க்கலாம். இன்னும் 7th one is very interesting, ma. Seventh one, please. Let me write the function. 7th one, f of x is mod x plus 3 minus 2x, 6x plus 2 in various intervals. These 3 are not for the same interval. For the same interval means they must be same. For the different intervals, they are different values. If x is less than equal to minus 3, if minus 3 is less than x and less than 3, if x is more than or equal to 3, how beautiful it is. How beautiful it is. Suppose if you can draw a number line for these intervals, how interesting they are, just for 3, right? Minus 3. These are the two numbers you could see here. Minus 3 and 3. Only two numbers you see, yes. Just watch. Friends, here, this one is what, ma? This one is what? Between minus 3 and 3, ma. X lies between minus 3 and 3. This is the second one. This is the second one. This is the first one, yes. This is the third one, yes. Follow, please. Friends, minus 3 to 3, second one. What is the function, yes? Minus 2x. Do you agree, ma? What is the function? Minus 2x. X is less than or equal to minus 3, ma. X is less than or equal to minus 3 in the this one value. What is the function, yes? In the set, this called first area, ma. I am talking about first x is less than or equal to minus 3. What is the function, yes? Mod x plus 3. My third area is here, ma. X is more than or equal to 3. This is my third area. What is function for third one? 6x plus 2. I hope all are listening, right? Yeah, right. Friends, the number line drop panna romba armiya irukku. You could see this. 1, not first one. 1, 2, 3, mind just mark it, demark it. And see that minus 3 kilo vandu you have one function, first function. Between minus 3 and 3 mark. This is between minus 3 and 3. This is the second interval mark. And function 1 minus 2x, yes. Then above 3, there is a third interval, yes, above 3, third interval, the function is 6x plus 2. In the morning, see, yes, when I speak about minus 3 minus inga. Minus 3 plus inga. Purida, please. Minus 3 minus 3 plus on the right side, minus on the negative side, left side. 3 plus 3 minus. Further, see the borders. 3 plus in the function. 3 minus in the function. Yes, please. In the morning, please prepare pannunga for all questions. Last time I didn't say like this. Okay. Somewhat they are confused. Now I think you are blessed with it. Please carry on with this. Okay. That's all. Now you can kill this now, please. Okay. One more point now. What is the graph of mod x now, please? If y equal to mod x, what is the graph now? Anybody? Correct? Y is mod
Yes,
x
sir.
plus 3. Y is mod x plus 3 on the graph equal.
In the y-axis, we should start.
Yeah, starting is 3. 3 plus mod. 3 plus mod x. 3 in 3 by mod x. Or mod x minus 3 and another question.
Sir, in
X minus this problem. Put x equal to 3. At x equal to 3. 3 minus 3. Y is 0. Rest of 3 comma 0 ds. Please. Y equal to x plus 3 modulus. Minus 3 mark. Minus 3 you get a V mark. That's it. In the way y equal to mod x minus 3 and minus 3 in the start add. Okay? Starting is this. I hope it is clear, right?
yes,
All
sir.
of you guys and boys, please say one big guess.
Yes, sir.
Nice. Okay. Okay, right. But in the mod x plus 3 under function parma, when it is a 3 minus, okay, minus 3 minus 3 minus, is it continuous or not? Anyway, let us go for that. Okay. These things are side inputs. This function is minus 2x. Right, now I just complete here. First is, I didn't complete the question, ma. Find all the points of discontinuity of f defined by, okay? Find all the points of discontinuity. Find all the points of discontinuity. Yes. For the functions, yes. Number 1, First one, there are two numbers now. One is -3, other one is 3 ds. That means we are discussing the continuity of a function at x equal to 3 and x equal to -3. That's all. And formula -3 plus -3 minus and -3. Please. Limit at x equal to -3 ds. I am discussing a continuity of function at x equal to -3 ds. Come on. Tell me what the formula, Akshaya, please tell me formula here. Limit x tends to -3 plus f of x. Limit -3 minus f of x and f of -3. Yes or no, dears? Yes. What is f of -3, ma? Anybody, please? Who will give the answer for what is f of -3? Anybody?
Mod x
Yes, pa?
plus 3.
For -3, ma, equal to -3 ds. Again, for ma, -3. It comes for the first function, ma, -3 is in the first interval. Therefore, the function is this one, mod x plus 3 minus. So, x was the -3, ma.
Sir,
-3 ds. What is the
plus
answer,
3,
ma?
sir.
0. Yeah, ma?
Mod x plus 3, sir, not mod of x plus 3, sir.
No. Mod x plus 3, correct. Oh my God, what am I writing here? Sorry. Okay. Mod x plus 3 ds. So, x was what are you putting for x, ma? -3. This -3 what a modulus in the 3. 3 plus 3 and 6. Wonderful. We have done this. For -3 plus Harini, limit x tends to -3, -3 plus. What is the function here? -3 plus what is the function, please? -3 plus -3
-2x, sir.
Minus 2x.
-2x. So, substitute -3 for yes, pa. வரம்மா, நான் இன்னும் கிளாஸ்ல இருக்கப்பா, கொஞ்சம் முடிச்சுட்டு வரேன். ரைட்மா, நான் வரேன். அம்மா சொல்லிருக்காங்க அப்பவே. அப்படியே ரைட்மா, ரைட், ஓகே. ரைட்மா. So, clear மாதிரி -2 x by என்ன போடணும்ப்பா, -3 போடணும். It becomes 6 ds. Okay. Then limit சின்னதா எழுதலாம். X tends to -3 minus 1. Akshaya, what is -3 minus here? Function என்னமா -3 minus? For a -3 and -3 minus, same function x plus 3 mod x plus 3. Therefore, already you have done it is 6 only. Mod x plus 3. Therefore, it is 6 only. So 6, 6, 6. All of them are equal to 6. Hence, it is a continuous at x equal to -3 ma. Clear? Is it okay, pa? Clear?
Yes, sir.
Look at this one, ma. 3. Next to -3 is over, ma. We have calculated that at -3 it is continuous. Let us see for 3 months. For 3, can you definition for Solomia, please? Limit x tends to 3 plus f of x 3 plus limit. Okay. 3 plus ki enna function pa Hare Krishna? 3 plus ki enna function raja?
X plus 2, sir.
6x plus 2, brilliant pa. 6x plus 2 diya. So you should put for x what you should substitute ma? 3 you should substitute here. 6 into 3 plus 2, that is called 18 plus 2 is 20 years. Limit. Mamati, 3 minus there. Come on, 3 minus, what is the function ma, please?
Mod x plus 3, sir.
Hey, hey, 3 minus ma, 3 minus, wait, relax and say, yes. 3 minus ma, 3 minus ma, not minus 3 minus ma, please. 3 minus here, 3 minus.
6x plus 2, sir.
Hey, come on, listen. Hey, inga paarunga. 3 inga irukka paruga, 3 inga irukka paruga. 3 is here. 3 plus anna idu ma. Okay? 3 minus anna idu ma. So what is the function?
Minus 2x, sir.
Minus 2x. Very, very clear. Very nice. Minus 2. X by enna podranappa? 3 podanum. That is minus 6. Array 20 is not equal to minus 6. We did not go for third one. These two are not equal. That's it. So it is not continuous. It is not continuous at x equal to 3. At x equal to 3, we are talking about x equal to 3, my dear. I think this confusion about here. At x equal to 3, my dear. At x equal to 3, the function f of x is not continuous. That means what? Discontinuous. So find all the points of discontinuity. 3 is the only point of discontinuity, my dears. 3 is the only point of discontinuity. Sir, idhukku graph eludha mudiyuma? Just let us see the graph if possible. If you can do the graphs to the possible extent, you will be superb in mathematics and physics also. Okay? We can do the graph. And you will find that only at 3 the function is not continuous. Okay? Right. Find all the points of discontinuity. Only point is 3 mark. 3 is the only point of discontinuity, dears. Now, graph identity, you can get the idea of the continuity and discontinuity. Okay? So minus 3 is continuous. At 3, it is not continuous. Now, drawing that number line for the split function is the new revelation. Last time you will teach Pannamudu, they were not that lucky to. Yes or no, Hari? Even Hare Krishna was there. Yes,
Yes,
Hari?
sir.
Yes, it was not that. See, now I am improved or not? Yes, please. Did I improvise it? Yes. If there is a will, there is a way, yes. So we always think about how to improve ourselves. Okay? We can. Yes. Friends, here the graph eppadi eludradana first one x is less than or equal to minus 3. This is minus 3 years. Okay? At this minus 3, it is a mod x plus 3 mark. 3 line or drop. This is called 3 line. Y equal to 3. The 3 line mela minus 3 kita vandu neenga modulus function drop pannunga podum. That's all it is. That is the number 1. Okay? This is called 3 mark. Friends, next is, for this I say that y equal to minus 2x. For this y equal to mod x plus 3 mark. Sir, idenna sir certain y eludinga certain rendu varudama. Right either y or f of x. Third one is y equals to 6x plus 2 ds in the interval of this. more than 3 my dears, more than 3 அண்ணா இங்க வரும் x is more than 3 dears, x is more than 3, இது 0 மாதிரி, இது 3 ன்னு வெச்சுக்கோங்க. more than 3 அண்ணா இது இங்க more than 3 or more than or equal to, more than or equal to including 3 dears. At 3 and above, what is the function here? 6x plus 2 ma. And x, y and point equal to 2 ma. X equal to 0, y equal to 2. Please. X equal to 1, y equal to 8. Wow, that's it. 0, 2 only in the world. This is 0, 2. Yeah. 2. And 1, 8. 1, 8. This is the line. This is the line, but it's more than or equal to 3 by the whole by the whole. இந்த மட்டும் பண்ணலாம், இங்க என்ன பண்ணலாம்? நமக்கு வந்து from only above 3 we should draw it now. This is the thing. இங்க ஒன்னு இருக்குது, அங்க ஒன்னு இருக்குது. Next வந்து in between 3 and minus 3 the function is minus 2x. Minus 2x னா எப்படி வருதுன்னா பாருங்க, how beautiful it is. Y equal to x னா exactly through horizon but 45 degree now. Y is minus 2x னா இந்த சைடு இப்படி வரும். 2x னா இப்படி. Okay. Y. 6x plus 2. 0, 2. 1, 8. Minus 2 slope. What is that? Minus 2x. Minus 2x. 2, 0, 2. Let's find out. Y equal to minus 2x எப்படி draw பண்றது? Slope is minus 2 ma. Minus 2 னா okay, பண்ணலாம். Y equal to minus 2x. Put x equal to 0. Y is also equal to 0. Fantastic. And x equal to 2. Y is minus 4. So 0, 0 இங்க இருக்குது. And 2, minus 4. 2, minus 4 இங்க வருது. Maybe between minus 3 and 3. Okay. This is at x equal to minus 3, it becomes minus 6, right? Minus 6. 0, 0 and 2 minus 4. 2 minus 4 is correct. This is at x equal to minus 3. Minus 3 is 6. Correct. 6 correct. That's all. நீங்க பாருங்க, ப்ளீஸ் தயவு செய்து பாருங்க. இன்னும் கொஞ்சம் மேல போயிடும். But is there any connection from here to here? At 3 பாருங்க. At 3, yes. At minus 3 it will go. Okay. At minus 3 it will go. The connection there. பாருங்க 3 வந்து பாருங்க 3. இந்த கிராஃப் பாருங்க. இந்த கிராஃப் பாருங்க. We will connect these two. At 3 it is not continuous, my dears. That's all, yes. I think time up. You are all waiting for it. Question number 7. From a graph through graph also, we can find out that at 3, at x equal to 3, you can't connect these two values. At x equal to minus 3, fantastic. So one graph is enough, my dears, to say it is discontinuous. Yes. Thank you, thank you very much. How was the class? Are you able to follow, dears?
Yes, sir.
Yes, sir.
Thank you very much. We'll see tomorrow again, or if possible, one more session in the afternoon. No other classes, right? Only mathematics or what?
Mathematics and zoology, sir.
Zoology is there. Okay, right. So I will take up one more class. I will see it and I will schedule it now. Okay, just to be, I will send a message also. Don't worry. Okay, I'll inform you in prayer. Thank you, Paul. Thank you very much.
Thank you, sir.